Hey guys, so in this video on the mathematical systems we are going to learn the Euclidean axioms. What is an axiom? Axiom is a statement that is taken to be true and there is no proof required. What it means is that we don't need to prove anything for this statement. We can just accept it as it is true. Okay, so there are about 7 axioms that we are going to learn. In that I will cover about 4 of them in this video and 3 in the next video, right? Okay, so the first axiom says that things which are equal to the same thing are equal to one another. So I'll use some fruits to explain what it means. The first axiom. So I will use orange, apple and plums as well, right? So the first statement says things which are equal to the same thing, right? What it means is that the weight of 2 oranges, right, is equal to the weight of 1 apple. So now also the weight of 3 plums is equal to one apple as well, right? Okay, so now you tell me the weight of plums, the 3 plums and the weight of 2 oranges, are they equal or not? Yes, they are equal, right? Because 2 oranges weight is equal to 1 apple, as well as 3 plums weight is also equal to 1 apple's weight. So the weight of 2 oranges as well as the 3 plums are also equal. So that is what it means, right? The things which are equal to the same thing are equal to one another. So these two are the weight of these two, orange as well as the plums are equal to 1 apple. That's why the weight of these two also is what? Equal. Yes, that's right. So now let's see how and what it means in the geometry, before going to the second axiom. Now you see here the length of the line segment AB is equal to the length of XY. The line segment XY, and also this line segment OP, the length of OP is equal to the line segment what? XY also. What do I mean by that? The line segment AB is equal to the line segment XY. Also the line segment OP is equal to the line segment XY. Now you tell me if the AB and OP are equal or not. Yes, they are equal. Why? Because they are equal to the length of what? XY. Therefore what? AB line segment is equal to the line segment OP, right? So this is applicable for not only this kind of line or anything. You can use it for any other geometrical stuff as well, right? So the line is the simplest one that we can make use of these axioms to explain, to understand better. So now let's go to the next axiom. The next axiom says if equals are added to equals, the wholes are equal, right? So now what it means is that the weight of 1 plum is equal to the weight of 1 tomato. So that's one thing. And the weight of 1 orange is equal to the weight of 1 apple. This is small apple, not the previous apple. Careful. Right? Okay. So now, as per the second statement, if the equals are added, the wholes are also equals, right? What it means is that now I'm adding the plum to this orange and also the tomato to the apple side. So now you tell me whether the weight of these two together and then these two together, are they equal or not? Yes, they are equal, right? So that is what the second axiom says. If the equals are added to equals, the wholes are equals. So originally, right, the orange was equal to the weight of the apple, right? And also the plum's weight was equal to the tomato's weight. Now we are adding them together. One side, the orange side, we are adding the plum. The apple side, we are adding the tomato, right? So now the weight of this side will always be equal to this side. That's the whole thing after adding them. right? So that is what the axiom 2 means. Let's see how it is, how we can understand from the geometrical stuff, right? See here, the line segment AB, yeah, is equal to the line segment XY, yeah. AB is equal to XY. So this one is done. We are done with it. Now we are in here, yeah. So AB is equal to XY. Now this OP is equal to MN, line segment MN. This one is equal to this one. This is equal to this one. Got it? Yeah. So if I have to use the fruits here, how I can say is that, the big line is orange, the small line probably is apple, and then did I say small line? No guys. Okay. So the big line, this one is orange and this one is apple. The length of this one is equal to the length of this one, right? Got it? Okay. So now for the smaller lines, right, the line segments, this if you take it as a plum and this as a tomato, they are also equal. Now we are going to add them together, right? We are going to add them together. Let's see how it translates, right? So AB, so in this line, A till here it's B, right? And then if you add the OP here, the O starts immediately, right? Because we are adding them together, and then it is till P, right? Till P. Now on this side, this is X, this point is X, and then it goes up to Y, and then we are adding the MN here. So M starts immediately and then it goes up to N. Got it, right? So now you see the total length of this one from A to P as well as X to N, are they equal or not? Yes, they are equal, right? So adding them together, adding the equals together, right, you will get the whole also will be equal. Whatever the end result will also be equal. So that is what the axiom 2 means, right? So now let's see the axiom 3. So what is the axiom 3 says? If equals are subtracted from equals, the remainders are equal. Now for this I will use the previous example. At the end what did we have? One plum, one orange. The weight of these two is equal to one tomato and one apple's weight, right? So that is where we were. But we also knew that the plum's weight is equal to the tomato's weight, right? So subtracting, right? What it says, if equals are subtracted from equals, then the remainders are equal. What it means is that the equals, which is the plum weight, is equals to the tomato's weight, right? So we are subtracting this from the total what? The total weight, right? So now I have removed the plum and tomato. Now you tell me whether the orange weight as well as the apple's weight, are they same or not? Yes, they are same, right? Because the same weight has been reduced from both the side. So the weight is still the weight of these two, right? What will become equal again. So that's what the axiom 3 means. Yeah. So what it says, if equals are subtracted from equals, then the remainders are equal. So let's see how it is, translated in the geometry, right? Now let's see here. Right, so let's take this as an example here, right? So from this length from A to P, what we are going to, right, deduct, subtract, yeah, subtract is that we will subtract the length AB, and same thing we will do here also. You know that this length is equal to this length, right? And also we know that AB is equal to XY, right? Got it, right? So now what we are going to do is we are going to subtract the AB. We are going to chop it off, right? And this side we are going to chop it off the XY. So what will be remaining here? This side what will be left with? OP, because you remove this one and here also you remove this one, XY, right? You remove that one. So you will be left with MN, right? So now you tell me whether the length of these two are equal or not. They are equal, because you see here, this is what we got back after subtracting equals, right? So if the equals are subtracted from equals, the remainder will be equal, right? This equal to this one, that's what we saw. So we subtracted another equal, which is this equal to this one, right? So we subtracted from both the side. The remainder are equal again, right? So what we got, OP is equal to MN. That's what we originally had. So that's what we got here as well, right? Got it? Yeah. Now we will learn the fourth axiom, right? The fourth axiom says things which coincide with one another are equal to one another. What it means is that, what is coinciding? Do you know that? Coincide means like sitting on top of it. Yeah, got it? I'll explain. So far we used the fruits. Now I will use the bowls that I used for keeping the fruits. Yes. Why I'm using all these things? Because these things you can see every day in your life. So maths is not a kind of rocket science. Yeah. Everything that you see around you, you use maths. Yeah, mathematics to kind of think about a particular object. Yeah. So now let's see the fourth axiom. Things which coincide with one another are equal to one another. What it means is that now you see here this bowl. Yeah. Now coinciding means you put on top of it the other one. Now what will happen is you cannot see the one that is behind. Right? You cannot see it, right? Now if you see, right, if you exchange the bowl also, you cannot see the one that is behind it, the one that is behind, right? So what it means is that it exactly fits on one another, each other, right? So that's what it means, right? Things which coincide with one another are equal to one another. Got it, right? So now let's see what we can use in the geometry to understand this one. Yeah. So for that I'm going to draw two planes. So I have paused the video and then I drew these two planes. Yeah. Why? Because otherwise the video will go too long before I finish drawing these two planes. Yeah. Okay. Right. Okay. See here. The plane A and plane B, right? Plane B, or this is a square and this is another square as well. Right? Now you see, if you take this square and exactly fit on this one, right, it will exactly fit on top of it, right? So it will exactly coincide on the plane, right? So A can coincide on B, B can coincide on A. So that is why these planes are equal. So that's what the axiom 4, right guys? Okay. So we have covered the 4 axioms in this video, right? So in the next video, I'll cover the remaining 3 axioms. And don't forget to subscribe the YouTube channel, yeah? Thanks.